Hi, my name is Gary Cernverta. Well, hopefully I've got a few listeners to come in on this first podcast. Maybe there's one person out there who's watching, so welcome. I'll be talking about all things related to AI, artificial intelligence. I mean, I hate that term, but that's why I'm here doing this. I'm just tired of all the hype and exaggeration about what this technology is, what it can do, the claims that it's going to kill all of humanity. This is all ridiculous hype, and I felt that I had something to say, being an expert in the field, having worked in this field for over 30 years in the commercial world. I want to share my opinions, debunk some myths, and I may talk about other things along the way as well in terms of how to practically apply these things to business and talk about business and my experiences. So I think in general, what motivated me to do this was the hype around AI and the debunking that. But the goal is just to share some of my thoughts and experience that I think would be helpful to folks interested in startups and technology and getting the real deal about what AI actually is and what it isn't. Well, I think today, I want to talk today about just debunking some of the, or just making some definitions about what is AI, what it is, and talking about how you need to think about the scientific method, which has been done for hundreds of years, how computer science seems to have ignored that and turned that inside and out, and then defining some of the terms around what is machine learning, what is AI, what's a theory, doing theory-based intelligence. Yeah, so just to define a couple of things, like supervised learning is a term I'll use. So supervised learning would be when you have known answers in your data, either historical data where let's say you're predicting fraud or not fraud, or sick or not sick, or you're trying to forecast the sales number. It means you have historical data where you have the outcome, the outcome. So you have historical data where if a record was fraud or not fraud, or if somebody's medical measurements were sick or not sick, or you have historical sales data about a product. So you can use that history where the answer, and you can train a mathematical model to be good at predicting the answer, and you can measure the accuracy of it in history. So the idea is if you can train it on known history, then you kind of know the accuracy of it, so that when you apply it in the future to unknown history, you have some sense of how it will work. So that's what's called supervised learning. And in its simplest form, supervised learning was invented, in the early 1805. Linear regression is the simplest form of supervised learning, where you try to fit the historical patterns with a straight line. So you can have a straight line, or if in multiple dimensions, it would be a plane. In 2 dimensions, it's a line. If you remember from your high school math, y equals mx plus b, that's an equation for a line. And you're saying try to fit the best line to some data points. And if it's in multiple dimensions, try to fit the best plane to a bunch of data points. And so that's was invented in 1805, linear regression. So that's the simplest form. And then now there's more sophisticated learners. The most recent advanced form is deep learning, which is really just applying deep learning. It really speaks to a neural network, which is an analogy for the human brain, a very weak analogy, because it's not how the brain works, contrary to popular opinion. We don't know how the brain works. Anyways, the neural network is kind of motivated, and academics usually take motivations from the real world. And so there's a good motivation on a neural networks, kind of modeling the linkages to the brain. So supervised learning would be like above, like in the taxonomy. Deep learning is one method which can be used for supervised learning, so it can solve the supervised learning problem. So a deep learning is a class of algorithms that use. So there could be different types of deep learning. So it would be like a hierarchy. So at the very top, it could be, call it data analysis. Then there's supervised learning. Then there's unsupervised learning. Then there could be optimization and reinforcement learning. So you could draw a tree. So deep learning would be a class of algorithms that are set up using neural nets, like deep, large neural nets, and so it'd be a class. So supervised learning is just a type of problem setup where you know the answers historically, and linear regression is a way to solve that. Different algorithms are ways to solve that. And so deep learning is just a very large neural network with multiple layers inside of it, which is why it's called deep. It has deep layers, and this has really been enabled by not advances in the software, it's advances in computing power. The fact fact that you hear about Moore's law and computers can, every year they double computing performance, and that's kind of slowed down lately, a whole nother topic. But in general, computer performance has doubled every year for the last 20 years. So it's the enabling of more computing power, which has enabled us to run larger and larger neural nets. And in the 90s and 2000s, when computers weren't as big, neural nets kind of got excited. The world got excited, then it went away because we didn't have powerful enough computers. But now that we can run very, very large neural networks using deep learning, a few tips and tricks we use to train these networks, we can actually do more useful or more complex models. So, but the problem set up for deep learning, if you're doing supervised deep learning, is the same as for simple linear regression. You have data where you know the answer, and you're trying to build a mathematical model, and deep learning is just a mathematical model of how you there's a certain mathematical structure to that, which is an equation you could actually write out on a piece of paper, way more complex than y equals mx plus b. It could have billions of terms in it because you have very large neural networks, but it's fitting a certain mathematical structure to cloud of data points. That's essentially what supervised learning is. And so that is not AI. Okay, this is statistical analysis. This is a human-led statistical analysis. It's not artificial intelligence. It's a human pulling the data, assembling the problem, setting up the data, getting labels, and it's running an algorithm. For me, artificial intelligence should at least be autonomous, that it's a system that lives on its own. It's whatever it does could be something very simple, like controlling a thermostat. A thermostat would be the simplest example of artificial intelligence. It's autonomous. You set a temperature and it tries to manage your house at a temperature. You're not running back and forth to it every second, touching it. It's based on very simple software. It says that if the temperature is colder than you want it, then it turns the heat on, turns the fan on. If it's hotter than you want it, then it turns air conditioning on. It's based on the laws of physics. It says if you add heat to a box, add heat to an insulated box, it will get warmer. If you add cool to an insulated box, it would get colder. That's the laws of physics say that. That's Newton's law of cooling and the first and second and third law of thermodynamics. And so based on a scientific method, we built a system rather than a human being stoking a fire. So if you're trying to keep a house regulated with a fireplace, how hard is that to keep the temperature at 71 degrees Fahrenheit with a fireplace? Very difficult, right? How many logs do you put in? How dense are the logs? How often do you need to stoke it? So if you ever heated a home with a fireplace, it's either perpetually too hot or too cold. It's like just perfect for 5 minutes, right? Whereas the thermostat kind of automates what humans are not good at, which is keeping a room at a certain temperature when the temperature outside is much hotter or much colder than you want it to be. When it's 71 degrees Fahrenheit outside, you just open the windows, right? But that for me is, at least it's got to be autonomous as a simple definition. And ideally, we're using this technology to do something that people can't, right? Ultimately, the artificial intelligence is way overblown. Like a thermostat is like basically taking like the laws of physics and it's controlling. It's a controlled application. And there's many things like that, like like electricity generation, like systems, like it's controlled systems where we want to control its behavior and we have a desired outcome, aircraft, autopilots in aircraft, are that, like when the pilots don't sit there and hold on to the joystick and the yoke and the throttles, they set a direction and the computer flies along. Trajectory tracking is a form of autonomous system. So I'd say artificial intelligence it's like machine intelligence is the most elevated term I would use, or just an autonomous system that is trying to exhibit a behavior with no human in the loop. It could be following a path like trajectory tracking. It could be like the thermostat. It could be a fan blowing the air, monitoring pollution, turning on an alarm if the pollution level gets too high. Like there's all kinds of systems that are autonomous, that have some algorithm that's typically based on some law of physics, where we understand the behavior of the system and we can autonomously control that system. So it's very closely related to system control. And there are many control systems in factories like machinery and you know all kinds of factory processes are automated. And so I would say that's interesting. Like biological intelligence, like what we are or what like animals in nature are, so much more amazing than a computer program which does like curve fitting or even like the laws of probability, which when we say like, so if you put a random, like a lot of the software has a random number generator in it, where by doing random number, taking random guesses, you can exhibit learning by trying. So it's like if you have a billion monkeys pounding away at the keyboard, eventually they will write sentences if you have enough random examples, right? And so it's randomness with some guided control will eventually, with brute force computing, generate some what looks like intelligent behavior, but it's not really. It's just brute force computing. And I would say that's what most of things are. And just because you put a random number generator in the code, probability and statistics was invented in like the 1654, I think. Right? I forgot. I think it was Legendre was the guy who did linear regression, and maybe Gauss was probability and statistics, or vice versa. I can't remember. Look it up on Wikipedia. But like these things that people are all hyped about have been invented for hundreds of years. And if it was the panacea that everyone's like running around going, oh my God, it's going to control the world. Well, like shit, this stuff was invented hundreds of years ago. Like if that was the panacea, you think we would have figured out how to change human life. So I think it's massively overhyped. To say the least, like this idea of artificial general intelligence, machines becoming sentient. So just because we can compute really fast doesn't mean it will come to life. Right? Like just because you can add numbers a billion times a second, a trillion times a second, whatever, a gajillion times a second, does that mean it'll all of a sudden become alive just because you can do things faster? Like, I don't know, where's that come from, right? Like, so computing and sentience are two different things, and we have no comprehension or very little comprehension of how human intelligence goes. You can teach a baby what a cup is, give a human being 3 cups, and we know what a cup is for the rest of our lives. We'll never forget it. You have to show a computer a million images of a cup to be able to predict cups. And even then, if you change 1 pixel in a picture, you will change its prediction from a cup to a not a cup. Whereas a human being, you show it 3 examples. So obviously our learning ability is and how we learn is very different than a computer. And we don't understand the human brain completely. We have a very rudimentary, it's like, I mean, we used to drill holes. We still drill holes in people's head to treat brain injuries. Like this is like, we're like carpenters. Medicine is like carpentry to a large degree. It's like we overblow ourselves and think of ourselves as so gloriously advanced. And, I think it's a little bit of ego more often than not. So call it for what it is. It's technology, it's computer programming. And yes, it can be very useful, but it's not like the way people talk about it, killer robots, and like makes me insane just listening to that talk. They want to make money. It's all about money making, right? And so the academics, when somebody said neural network is like modeled after the human brain, and then the 30-second soundbite, the media says academics mimic human brain to do learning, and then the academic goes, ooh, I got quoted in the public, I'm going to be famous. And then they go out and make these analogies, and media takes 10-second sound bites out of every conversation, and all of a sudden the academic guy is getting called for interviews, and his speaking fees just went from nothing to $10,000 for a 10-minute talk. All of a sudden it's like, wow, I can keep talking bullshit and make millions of dollars. Man, this is awesome. And the world is, everything is condensed to a 30-second TikTok video, so nobody has the time to actually sit down and learn anything. Like, I'm sorry, like the expertise takes years and decades to develop. Like, we're in a gigantic rush, and the world isn't wanting to take the time it's required to understand and learn. And so, yeah, we live in this 30-second soundbite world, and unfortunately, much of the world is not consumable in 30-second sound bites. So, and reporters are classic for taking things out of context. And then the people misquoted, all the people misquoted, I can guarantee you, and I won't name the names, but you know the names, they are all multi-bajillionaires now, and they weren't like 10 years ago. Okay. So, right. So the almighty dollar, I think, is driving this more than not to the benefit of humanity. I think these people think it's to the benefit of humanity, and there is an altruistic motive in there that they're thinking this is good for humanity. But I think a lot of things get in the way of that, right? And I think ultimately, most of us in this field, or I mean anywhere, we're trying to do something positive to help mankind, right? There hasn't been a single thing in this human world that has been built with a supervised learning model. Like the chair I'm sitting in, the laptop I'm on, quantum mechanics led to the laptop. Okay, quantum mechanics is not a statistical linear regression model. Statistics and machine learning are tools used by scientists to analyze data, but scientific theories come from the human mind. And that's when I talk about the causal theory. And this is the way science has been done for hundreds of years since the Renaissance. Science came up with a description of the world, typically a mathematical description, and then we test it. We get the data to test, does this theory work or not? Like the example I'll talk about later, the orbital mechanics example. Does my theory work or not? No, it doesn't predict it. Then you alter the theory, you iterate. Like, so it's theory first, data second, test it, iterate, advance the common knowledge, express it in terms of some kind of mathematical theory. These statistical supervised learning, machine learning, even unsupervised learning are just data analysis tools that help you analyze data. They're not the creation of knowledge necessarily. They can contribute to snippets of knowledge that then are assembled into theories, mathematical theories. But like the laws of physics have been invented by scientists who came up with a theoretical foundation first, and everything in our life was built with a scientific method. Like literally not a single thing was developed with statistical analysis. And maybe I'm wrong. Somebody will come out of the woodwork, and I hope they do, and say, Gary, you don't know what you're talking about. This was invented with statistical analysis. Okay, great. 98% of things were invented with a scientific method. And that's the way we have done science. And for some reason, the computer science people have now dominated this conversation about AI. Computer science should not be the owners of the AI. This is an engineering problem. This is system. When we talk about a system, is artificial intelligence should be a system, like an entity. And we know how to deal with systems. We have control systems. That's what engineers do. We have like autonomous control and control theory and how to control systems. Like we want our AI systems to be well behaved. Not only is the false positive rate, what if the AI system was really wrong sometimes? What if it said, this guy's a criminal, kill him now? Oh shit, I made a mistake. Like you could be egregiously wrong, right? And we don't know. Like ChatGPT has proven there's no way we can a priori approve it's correct, right? So what if you analyzed a legal case and you found this guy guilty, and then you put him to the death penalty, and then you realized it was wrong? Like, like we need to have stability and consistency in our systems. Well, how do we do that? We have control theory. We factories say, if this pipe gets more than 100 degrees Celsius, it's going to explode and kill everyone in the plant. Let's shut the plant off. We monitor systems. That's called a control system. It's a safety system. So how do we know? Like if I went to one of our retail clients and said, hey, you should order 1 million tons of bananas this week for your banana promotion. And then 10 minutes later, I go, whoops, I didn't mean 1 million. I only meant 1,000 tons. And then, it's not like I killed anybody, but I could have put them out of business. So how do you stop an AI system from ever making a mistake that egregious? Right. So that's called control, stability and control, that we can't be 1 week saying order 1 million tons of bananas and the next week saying order 7 tons of bananas and then 1 million and 10 and 300,000 and 4. Our decisions can't wildly oscillate. They need to be stable and controllable. And there's a whole branch of mathematics called control theory. We need to integrate control theory with these decision-making systems. That's why it's a system. The other thing is repeatability. If you have random number generators in your software and it's not deterministic, that means if you run the software twice in a row, you could get 2 different answers because there's a random number generator in there. So now if I run my process and I run, here's the optimal 100 items for the customer this week to promote, and I ran my software twice, do I get the same 100 items 2 times in a row? What if you don't, right? That's why on the Mars lunar lander, when it's screaming through the atmosphere and says deciding when do I pull the chute to start slowing down, and there's not one computer system on the lander, there's at least two, maybe three or four, like all these engineering systems have backups, right? And the main computer goes pull the chute, and the secondary computer goes don't pull the chute, and the third computer system goes pull the chute. What do you think the computer does? It it does an analysis of which one should I listen to? What's the safest thing to do? What's the least safe thing to do? And it does a quick ensemble thing, right? So that's called like fault tolerance. So do we talk about fault tolerance? What if you run your deep learning algorithm twice on that image of a cat that's telling your car to hit the brakes? And the first one says that's not a cat, it's just a piece of paper blown by, and then you run over the cat and kill it because your braking system didn't go on. Versus, the second time you ran it, oh, I did get the picture of the cat right because it was 1 millimeter off in the frame, and I was able to get that one right. And then when it moved another inch, it was a paper bag again. And do we understand the behavior systems like that? So if we're using these systems to make decisions, when we do the MRI analysis, are we analyzing the MRI 10,000 times and making sure that we get the same result 98% of the time? Is it wrapped in Monte Carlo simulation? Something we know very well about doing Monte Carlo simulation. So there's a lot of features of artificial intelligence systems that are not even topics of conversation: stability and control, repeatability, safety, not doing the wrong thing. And we have algorithms for all of these. There's like these have been invented for centuries. Like there's like I forget the name of it off the top of my head, but there's this one fault tolerance algorithm which was invented in times of war, before there was like ways of communicating with radios. It's like from like the medieval times, or even before that, like in pre-Christian history, going to war. Like when you send your generals a message and you have 10 generals circulating a town and you send them a message that say attack now, how do you know that they all got the message and the right message and they're doing the right thing? Like, so there's an algorithm that you can do to try to get everyone to do the same thing when you're not able to communicate in real time. And yeah, so we don't talk about any of this stuff, right? And it's going to control, it's going to kill everybody, it'll become Terminator. We're like, it's so idiotic. Like the conversation is 1 micrometer deep, and we're dealing with an ocean like the Marianas Trench, and we're talking about the top millimeter of the ocean, yet there's a whole depth of an ocean to be plumbed that nobody is talking about in the public, and they're scaring the shit out of all of humanity with the BS and hype. And this people are making a bajillion dollars and raising billions of dollars on this stuff that who knows what the hell it will do. We have no idea what it'll do, and except make those people rich, right? And get a lot of media attention. 99.9% of the companies who say they're doing AI, that's not autonomous systems. It's just human. If there's a human being typing shit on a keyboard, that's like data analysis, human-led data analysis. Take the human out of the loop at a very minimum. Be able to simulate, be able to operate autonomously. These are, at least in my mind, some minimum requirement to be called a system, right? That it's operates on its own, right? An autonomous system. And thanks for tuning in. I hope you enjoyed the rants that I shared with you today. And if you found this valuable, please come again. Tell your friends if you saw anything valuable. Would love questions, would love you to debate. If you think I'm smoking rope, like, please feel free to tell me. I don't take that personally. In fact, I really want that. I think, I want the dialogue. I live in my own thoughts a lot, having been in this space, and I don't get challenged a lot. I think there's for whatever reason, there's not a lot of people challenging. I guess maybe I get a little too excited and they're intimidated by that, but I welcome the challenge and conversation and dialogue. So please tune in. And if you have questions and you want some more explanation about something I said, happy to do that too. It's not only targeted for deep technical conversations. I think lay people as well. I think it's important to share what is and what reality, what the truth is versus not the truth. Not that I'm the arbiter of the truth, but I think being more factually honest than dishonest, I think is what I'm striving for. And I think it's for everyone to have a better sense of that, I think would hopefully contribute positively to this dialogue. So maybe someday we'll have guests on the show as well who might want to debate with me or just have a conversation if they agree or disagree. I would love to have those conversations with folks. So if you want to come on and talk and we can have a chat and record that, that would be fun too.